so this is the last page. So number 10, again, is from 3.8. And you have to stretch it vertically by a factor of 3 and then move 1 unit to the right. So 3 times f of x means you are just distributing the 3. So that's what I did first. So 3 times 3x squared, 9x squared, times 3 is negative 3x. 1 times 3 is 3. Now you have to do 1 unit to the right. So this is where things can get kind of tricky for people. So you have to replace x with x minus 1. And that means you're going to have to do some simplifying. And this means you might have to do some foiling. If you have something that's cubic, then you'll have to use Pascal's triangle or write it out 3 times. We are going to go over our 3/8 today so you can see what that would look like. So x minus 1 squared, be careful. You have to FOIL. X times x is x squared. Negative 1x minus 1x is negative 2x. And negative 1 times negative 1 is 1. Okay, I'm telling you right now, a missed thing is people will do x squared plus 1. You have to write this out in FOIL. And then you're going to distribute here. So negative 3x plus 3. Okay, and then you're going to combine your like terms. This will be your final answer. Yeah, Alex, question?
So, I have a question on A.
Yeah.
So, like, if we were, what I did, like, I did this extra, I don't know if we have to do this, but, like, since they all have a common term, which is 3, I, like, took the 3 out. Would that still be right, or would we do, is that, like, too much to do?
Yeah, you don't want to do that because really they all have a common term of 3 once you do the vertical stretch.
Okay.
So you distribute the 3, so you don't want to pull that back.
Okay, that makes sense.
Okay. Because then really you'd just be undoing what you did.
Okay.
And then let's look at B as well. So again, just be careful about this. If you need to write down an example, you can do that on your note card. This says to compress horizontally by a factor of 1/2 and a shift of 2 units down. So sometimes people forget with horizontal, you have to use the reciprocal. Okay, so maybe you want to write down the rule, maybe you want an example, maybe you just want to write yourself a note. Just decide what you need, what's going to help you the most. So this would be f of 2x, and then the 2 units down is minus 2. Okay, so I replaced every x with a 2x, and then the minus 2 is just going to go right on the end because these are going to be like terms. So again, 2x squared, you have to do that first where you do 2 squared, then you can multiply by 3. And that's going to give you 12x squared minus 2x minus 1. Okay, and then for C, you're reflecting across the y-axis and compressing vertically by a factor of 1/2. Okay, so when you do that, the first thing that you want to do is replace every x with the opposite, and then you can simplify. So negative x squared is x squared. 3 times x squared would just be 3x squared. Negative times a negative is a positive, and then I have my plus 1. Now, because this is a vertical stretch, I just have to distribute the 1/2 to everything. That's how I get my final answer. All right, so that was C, and then let's look at D. So for D, you're shifting 3 units right, 4 units up. So because you have the 3 units right, look and see what you have to do here. X minus 3 goes every place that you are that you had an x. And then if it's squared, you have to do what? How did I get x squared minus 6x plus 9? You FOIL, right? So x minus 3 times x minus 3. Write that out twice if you need to, and then FOIL. Distribute the negative. Add your like terms. Distribute the 3. You have some more like terms. And this is your final answer. The 3x squared minus 19x plus 35. Okay, so if you didn't get that right, I really hope that we are writing down the correct answers. I do post the blank copy of this, so if you wanted to print this out at home, or if you wanted to do some of the problems again to make sure that you know how, that would be great. for number 11? All right, so for number 11, we're going to do this step by step. So when you are writing a function and you have negative 1/2 of x inside, what that means is for the function g, you're going to have g of x equals x cubed minus 2x squared plus 3x minus 6. And then I go back and plug in negative 1/2 x, negative 1/2 x, negative 1/2 x. Okay, so if I have negative 1/2 to the third, I know that's going to stay negative. So 1 to the third is 1, 2 to the third is 8, so negative 1/8 x cubed minus 2. This is going to be positive because a negative 1/2 times a negative 1/2 is positive 1/4. This is x squared. When I have 3 times a half, it's just 3 over 2, right? 3/2 x minus 6. And then my last step is going to be to simplify here. Notice that I have negative 2 times 1/4. What's negative 2 over 4? Yeah, so it's going to be negative 1/2 x squared plus 3 over 2x minus 6. This is your g of x. Yeah, right?
Forgot to make the one with negative into the 3x.
Oh, thank you, thank you. Yes, for the x, yes, negative 1/2, right, so this should be minus. This should be minus. Thank you. Yep, negative 1/2, negative 1/2, negative 1/2. Good. Okay, so that's another thing to double check. See, it's usually something small. Sorry that my negative looks extra large there. All right, so we're going to do something similar for b, except instead of replacing it with the negative 1/2, I'm replacing it with negative x. So this is going to be negative x cubed minus 2 times negative x squared plus 3 times negative x minus 6. And then if you want, because this is a vertical shift down 2, you can just put your minus 2 on the end. What's going to happen is you're going to combine these like terms together. Okay, so negative x cubed is going to be negative x to the third. And then here, negative x squared is positive. Positive times negative is going to still be negative. Positive times a negative is going to be negative. And then negative 6 minus 2 is negative 8. Okay, check me. How'd I do? Did I get all the signs right? Then let's go to number 12. So number 12 says to use finite differences, okay, to determine the type of polynomial that best describes the data. Then you will write a polynomial function for the data given. So if it says that you have to use the finite differences, I need to see you finding the finite differences, okay? I'm going to show you my work for that. So the first difference is, this is going up, right? So it's 20, and then 10, 6, 8, and then 16. Okay, so these are the first differences. Are those constant? No. So that means it's not a what type of function? Linear. So now I'm going to find the second. If these are the same, it would be quadratic. Are these the same? Nope. So then I'm going to keep going. Okay, so this is up 6, up 6, up 6. Oh, that doesn't make me feel good. But these are the third differences. Okay, so third differences, these are the same. So then it's what type of function? Cubic. So if it's the third, then it is a cubic function. Okay, and if it is a table like this, you are going to use cubic reg. Okay, cubic regression. When you do that, you will get a value for A, B, C, and D. Okay, your function is f of x equals x cubed minus 2x squared plus 7x plus 6. Do we need a refresher of how to do that on the calculator?
No.
Well, maybe some people do. Okay, so this is where you press stat and then edit. Okay, and then this is -2, -1, 0, 1, 2, 3. And then you're going to put these in here. -24, -4, 6, 12, 20, 36. Okay, now you go to stat, arrow over to calc, and then this is going to be cubic regression. So you go to calculate, and there you go. Now this one is very nice and tidy. Notice that your r² value is 1. That's awesome. But when we are dealing with data, things are not always nice and tidy, are they? No. So remember, this one you're finding the finite differences, but for number 13, okay, what are you going to have to do? Mm-hmm.
Do you have to like put the numbers in like from the table and 0, 1, 2, 3, 4.
Yeah, you have to put the numbers in from the table, and then what?
And then you like kind of just use that table to find which generation is like the closest match.
So, yeah.
Regression, that's the word. Right?
And
Generation.
do you guys remember what value you're going to look at? Yes, so you have to look at the r² value. So you have to find, okay, where r² is closest to 1. Oops, I meant to say what, but I said 1. So find where r² is closest to 1, and what else do you have to watch out for? What is not 0? A. Okay, and A is not 0. So you have to find where r² is closest to 1, and A is not 0. Okay, so make sure that you do label these as the 0, 1, 2, 3, 4, 5, 6, 7, and then you would do the steps that I just did with this one, except you're going to do the linreg, you're going to do the quadreg, you're going to do the cubic reg, and you're going to do the quart reg. Okay, and what you're looking for is the r² value closest to 1 where your A value is not 0. Yes?
Why is there no like fifth reg? Like what about the fifth
It just doesn't have it on your calculator.
Or it does exist, it just
Yes, yep.
Okay.
And the higher these go up, and it depends on your data, the less accurate they can be. But yes, you can absolutely have functions that are higher than that and programs that can calculate that. Okay, and then quart reg, this just so happened to be 1 exactly. That might not be the case. Okay? So again, check to make sure that A does not equal 0. Do you guys remember what I told you to watch out for?
Low A values.
Yeah,
Round to 0.
that round to 0. Like sometimes they'll trick you, right? Like you'll look at it and it will seem like it's a number, but do you guys remember what you have to watch out for? Yeah, so it might be, and do you guys remember what that looks like? It might look like 6.789, but then it says e to the -5th. And then we know that that means that you're going to move it and it's going to round to 0. Okay, so this rounds to 0, so if that happened, that's a no. Okay? So then, because it is quart reg, you are going to get your function from there, which in this case was 7x to the 4th minus 180x cubed plus 1200x squared plus 1000. Okay, and that means that this is what you're going to use for the next part, where it says use f of x to predict what the average price will be in 2010. Okay, so the average price in 2010 means my x value would be what? What did you guys plug in for x? Yes, because it's 12 years since what?
1998.
Yes. 1998. Miss Whipple just graduated 8th grade, heading off to high school. True story.
Okay, so then you're just gonna plug it in. You guys weren't born yet in 1998, were you?
No, I would hope not. I'd be held back like.
Oh. What year were you guys born?
2005.
Oh, that's when I graduated college.
Oh,
Oh, wow. All right, and then so once you plug that in, your average price, okay, was approximately $7,912. All right. Now we're going to look at 3.8. Well, first, you guys have questions for me about this? How did that go? Uh-huh.
So do we not have to show our work for like the activity stuff in this class?
For this one, no, because it doesn't say to find the finite differences. So if it says to find the finite differences, you have to. But you absolutely could do that here. You could. But generally with the data, they don't always work out where it's a constant term. It could be close to each other. So you can use the R squared. That's